पल्लवी मैडम।
हाँ जी सर, बोलिए।
गुड मॉर्निंग।
गुड मॉर्निंग सर।
कैसे हैं?
बढ़िया सर, आप कैसे हैं?
मैं ठीक हूँ, थैंक यू। एक
वेलकम सर।
चीज थी आपसे,
हाँ
वो
जी।
शेड्यूल भेजा है ना जो लिंक के थ्रू, तो आउटलुक क्या है, वो एक्सेल आउटलुक हमको ऑपरेट करना पड़ता है। वो मैं मेरे लैपटॉप में नहीं कर पा रहा हूँ, मैंने 2 दिन से कोशिश करी मेरी। तो क्या ऐसा हो सकता है कि आप उसको एक्सेल में आपके पास बना हो तो सीधे ग्रुप में शेयर कर दे तो वहीं से पिक कर लेंगे उसको?
वी ट्राई टू डू। आपके क्वेरी को हम कैटर करेंगे। एक्सेल आउटलुक की बात कर रहे हो नहीं?
हाँ, वो मैं उसको कई बार कोशिश कर चुका हूँ, उससे ऑपरेट नहीं हो पा रहा है।
ठीक है। आपकी आवाज कट रही है हर सर।
हाँ, मतलब वो एक्सेल पे
ठीक है।
ऐसे
हाँ।
दूसरा नहीं कह रहा था मैडम कि वो अगर आप पीपीटी शेयर करेंगे तो वी आर एबल टू रीड। कुछ पूछने वाले हैं आएंगे तो भी स्टडी अबाउट ऑल सच
We'll try. We'll try to. हाँ।
है ना?
ठीक है। हाँ ठीक।
थैंक यू सो मच।
ओके, वेलकम सर। यू टू। Good morning, participants. Our resource person today is Dr. Preeti Sharma, and she'll join us from IIT Indore. She's an associate professor in IIT Indore, and she just is doing with the setup, and she'll take another 2 to 3 minutes to join. So thank you for waiting, and let's look forward to a very good and fruitful session.
Spotlight.
I'll do it. Good morning, Preeti ma'am.
Good morning. I'm so sorry. I was not able to get back to the same Zoom this thing. It kept on asking me create an ID. And I don't know, it does not go automatically in my computer system.
That is totally okay, not an issue. We are so glad that you're here finally. And with your permission, ma'am, we'll begin with your introduction. Dr. Sunita, my colleague, she's here for introduction. And then after that, we'll continue with your session.
Okay.
Is that okay? Okay.
Namaskar, respected Preeti ma'am. Good morning, dear all participants. I, Dr. Sunita Jaffer, welcome you, ma'am, and in the behalf of IBMR, IPS Academy, and Team STTP, it's my privilege to introduce you, ma'am, in front of my all participants. We have a participant from all over India. We have participants from Bihar, Delhi, Lucknow, and many more. And the majority of participants, ma'am, are from the economics and the finance area. So, dear participants, Preeti ma'am, she is a renowned faculty of IIT Indore in the area of agriculture economics. She is great faculty in the area of agriculture economics. She has given the remarkable work and in front of the government of India, especially related to the agriculture economics, microeconomics, and development economics, and even like is a lot of implication she has given with the help of economical areas. She has guided many PhD scholars, plus she has guided some postdoctoral scholars also, which is normally rare happening in India, especially in an economics area. Today, she is going to take our session, which is based on the panel data, fixed random effect, and fixed effect method and random effect method. And the entire session is going to conduct on the theoretical aspect and the stata and the e-views. So, Preeti ma'am, welcome you again. Now hand over to you. Thank you so much.
Thank you so much. Am I audible?
Yes, ma'am. Yes.
Okay. Thank you so much. Good morning, participants. It's indeed my pleasure that the IPS Academy has invited me for this STTP program. And it would be an interesting session, as earlier also in one of the workshops, we had a very interactive and very good session. And I would like to request, like last time, Dr. Pallavi had told me that what are the topics which have been already covered in the workshop. So I would like to request Dr. Pallavi to please share that.
Yes, for sure. Preeti ma'am, the first day we had started with introduction of econometrics, where Dr. Kavadia told us what econometrics is all about, methodology, the anatomy, the way he teaches was beautiful. Then the next session was on regression. So we had a faculty from Delhi University, and he was kind enough to actually show how to apply regression on data and how to interpret the results. That was the entire first day. The second day we had an elaboration of time series. What is time series? And unit root test and stationarity by Dr. Karunesh Saxena. And then we were joined by Dr. Jaishankar Bhattacharya from IIM Indore. He took a session on diff and diff. So he actually was explaining about his paper, how the treatment he applied, and what was the pre and the post analysis, and the treatment groups and the control groups. It was a story actually. So the only data application we had was in regression. Yeah, that's it. And today we are ready for panel data and fixed and random.
Okay. Okay, so what I will do is I will try that. First, I will talk about panel data in terms of the theory, that in what cases and under what assumptions we can use panel data, and what are the different kinds of panel data analysis, and then why do we choose one kind and then we drop that one and we move on to the next one, and then we drop that one and then we move on to the next one. So depending on what kind of outcomes you get at each stage, that is what is going to tell you which kind of analysis is most useful or most appropriate for your kind of data and your objectives of research. So so what we will do is in the first session, that is the first theory session right now, I will talk about the theory of panel data analysis, including the differencing indifference and pooled estimation, and then fixed effect, and then random effect. And in the second part, if I am able to cover this in the this 1.5 hours lecture itself, then in the second half, what we will do is we will do an example. And if we don't get a chance, of course, we will be able to do an example in our afternoon session, where I will have Dr. Pradhan with me, who did postdoctoral fellowship under me. So he is going to take a session on Stata as well as on e-views. So both the things he will do, and he will show you with the data set which I keep using often, which is of course related to agricultural productivity analysis.
Preeti ma'am, I would also request you, if it is possible, if you could send a part of that data set to me in email, so that we could email it to the participants. And if somebody actually wants to try hands-on practice while Dr. Pradhan is teaching, so that would be great, I think.
Okay, so what I will do around 11:35 or so, I will send you that email.
Yeah,
and so
sure.
you
That
can
would be
share
great.
that.
That would be great.
Yeah.
Thank you.
Okay. Okay. All right. So I'm not very well conversed with the Zoom platform, so I
Preeti ma'am, you see right at the bottom of your screen, you have a share screen icon.
Okay.
It's green color. Yes, we have given you the rights, so you can easily share your screen. Your PPT needs to be first opened in your desktop.
Okay, what I will do is, if you want, at the end of my sessions, I will share the PPT with you.
Okay, okay.
But right now, I would use a whiteboard.
Whiteboard? Yeah. Yes, yeah. The way you did in the last one.
Yeah.
That would be good.
Yeah, but this time I also have a prepared PPT. I mean, which has that, of course, which has text, which I will be anyway, kind of doing it one by one.
That you could share with us, and we'll share it with the participants. Right now, please be comfortable in using the whiteboard or whatever methodology. Yeah, yes.
Yeah.
And then you need to open the paint and share.
Yes. Yeah, I will do that. So, are you able to see the paint?
Yes.
Platform whiteboard. Okay.
Yeah, perfect.
All right. Okay. So, what we will do is,
Preeti ma'am, your video, I think it got mistakenly switched off.
Oh, okay. Yeah. All right. So what we are going to do in this session is, first we will talk about okay, in what cases do we use the panel data? As you have already gone through the introduction in this workshop, in which you would have already seen that we use an analysis where you have x or xi's, that is either a single variable, which is an explanatory variable, that xi or entire set of explanatory variables, the xi's, how do they have an impact on the dependent variable. So the two ways which you have already studied as of now are the cross section and time series. So as of now, what you have done is, in case of cross-section data, what you did was that you must be having the cases. So when you did that, you took several cases there and you analyzed those several cases in a given one time period. Okay. Whereas in case of time series, what you did was you had one case and you analyzed that one case over several time periods. Okay. Now, in case of panel data, the advantage of using panel data is that basically you're going to combine the cross section and the time series, wherein your data will be the kind where you have data in space and time. All right. So basically what you are going to do, you will have several cases like 1, 2, 3, like that. And you are going to observe those over different time periods. So T0, T1, T2, T3, like that. You are going to do you are going to note your observations, and in doing so, what you are basically doing is this kind of matrix, you are going to prepare that for your independent variable if your independent variable happens to be only one variable, or you will do it several times for your several independent variables, and also you will be making those observations for your y, which is your dependent variable. Okay, so you are going to have this kind of information for your several xis as well as for your dependent variable. All right, now what you are going to do is that now when you are collecting this kind of information, it is also possible that there can be two kinds of situations. One situation would be where your cases as 1, 2, 3, 4, the cases, they remain same. All right, that means that you are going to observe, this is the first type, and also we expect that in most of the cases, in most of the research, most of the times in your research, you will do this kind of panel estimation, or you will have this kind of panel data where your cases remain the same and your time periods are moving or are changing from T0 to Tn. The other kind, that is the second type of data, which also sometimes you have to analyze, is where your xi's, your variables, which are the independent variables, they remain the same, and your dependent variable also remains the same, but it is possible that the cases may not remain the same. So basically what you are doing is, in say suppose the case number 1 is in your sample is someone called Ramlal. Okay, now normally in your panel analysis, what we do is you are going to observe all the independent variables related to Mr. Ramlal and then see the impact of those on the dependent variable. Whereas in some cases, the case itself may not remain the same. So for example, in your next time period data set, your case number 1 is someone else like Shamlal. Now, this can be a situation which is seen often in case of the data which is analyzed when you are using the National Sample Survey Organization's databases. All right. So these two kinds of situations are also possible in case of panel data. So now when you are going to write these in your analysis, what basically you are going to do is that your pair of observation is denoted as YIT, all right, and XIT. All right. Now this pair of observations that you are going to make, here we need to note that this I denotes the individual unit. All right. And T denotes the subscript, which is corresponding to time. All right. Now, in the cases where we are going to do all our analysis, where we are considering that the case will remain the same and it will be analyzed over, or it will be observed over several time periods. Now, in the cases where your cases may change, in those cases, what we do is there is an analysis which is called independent pooled cross section. Okay. And in several of development studies research, National Sample Survey Organization's data is used, where they have large sets of cross-section data. All right, cross-section data for several individuals, where your dependent variable and your X size often remain same. In fact, it is also possible that in every round of NSSO data, you may get additional information on the independent variables which they might have identified, in order to see that how the welfare in the economy is increasing or not. All right. Now, in case of the panel data that is why panel data is very useful in conducting policy analysis, because it allows us to to note or observe the data across both control as well as your treatment groups. So in case when you are doing your policy analysis, panel data is important because you can make the observations for control group as well as treatment group. All right. Now, in case of panel data analysis, we need to also understand that two things we have to do is that we cannot assume that the observations, your observations, are independently distributed across time. Okay, this is an important point. Because there are two things here. What we are doing in case of panel data is that for each of those units, here we have noted those units. So for each of those units, there are two things which we need to take care of. One is the time constant attributes, and second is so time constant unobserved attributes and time variant unobserved attributes. So these are the two things which we need to deal with in our entire analysis. All right. So now what we can do also in case of panel data is that when we are collecting data for these several individuals over different time periods, then we can also create, there is also a possibility that we can create lagged explanatory variables. Lagged explanatory variables. All right. Now, this set of lagged explanatory variables can be utilized to estimate your distributed lag models. All right. Now, as I was already mentioning that we need to understand that we have to keep in mind the unobserved component of the data, which will have two components, that is the time constant as well as the time variant factors. All right. So now in order to do that, what we do is, I'm going to save this and change the board. March. Yes. So what we want to do is, when we want to observe our unobserved attributes, when we want to take care of the unobserved attributes, which have two components, one is the time variant and the other is the time constant attributes. So in order to do that, what we do is that we are going to enter our time constant component not as an intercept. All right. So that is a variable in our analysis. And that is generally denoted by AI, and in some cases it is also denoted as alpha I. Since it is time constant, therefore there will be no small t component, that is your time variance. Now, because of taking care of these unobserved attributes, what is happening is that we are basically in our analysis going to understand these, and that is why it is known as unobserved effects model. And the good thing or the merit of this is that it can capture heterogeneity. So please remember that we are going to do all our panel data in which we are going to address this component of heterogeneity. Now here, what we want is, we want to understand that we want to see whether, first, the things which we want to note down is that the correlation between AI and the independent variables xi, t is expected. The correlation between the time constant variable, which is going to give us the heterogeneity component, that and our independent variable, which is of course time variant, should not be correlated. So what it means is, what we can write is the covariance between XIT and mu IT should be equal to 0. And this, what does this mean is that the correlation between your time constant attribute and your independent variable is expected to be 0, and that is what is also going to ensure that what you have obtained as the estimator is unbiased and consistent as estimator. All right. Now, if we kind of combine, the time invariant or time constant component with our error term, which is mu IT, then if we were to combine the AI with mu IT, then the result will be, or this, what it is known as, is the composite error. We are going to do all of this with an example also. Right now I'm going through the theory, that what are the steps that we take into consideration. So this composite error is basically mu IT plus AI. Now, in such a case, what is done is, we can use a method which is known as method of differencing. Now, when we are using the method of differencing, what we are doing is, we are trying to remove unobserved effects. And when can we do that? When you are having a 2 time periods panel data. So when you are having a 2 time periods panel data, you can use this method of differencing, which is also known as difference in differences estimator. Difference in differences estimator. Can anyone think of an example here where we can use this kind of analysis?
Ma'am, in airlines, I guess, there are 5 to 6 airlines, and it can be used there.
For what? What do you want to analyze?
Ma'am, like you said, differencing.
Yeah.
So we will difference and remove the unobserved estimator.
Yeah, and what is your objective? What do you want to see in terms of the airlines? What is your target? What is your objective?
To remove the correlation.
Correlation between what?
Ma'am, the unobserved and error term which is created because of the error term and unobserved variable.
But I mean, how is this different than? So basically, what you are saying is that you are observing the. So basically, you are saying that you are observing the airline's performance. Is that
yes,
what you want to
yes,
say?
ma'am.
Okay,
Yes,
that was my question. So
yes,
you want to observe the performance of airlines over different time periods?
Yes, ma'am.
Okay, and in that you want to see, you want to
Like management is the unobserved, we can take as a unobserved, like AI you said, so we can say management is a unobserved variable there.
Okay. So can anyone think of any other more clearer example where you often have, see here I'm talking that in case of when you are going to use the differencing in difference method, then basically you want to analyze the change in, for example, in your example it is performance.
Yes, ma'am.
From one time period to another time period.
Yes, ma'am.
Okay. Now, can you think of an example where you expect that that kind of contrast will be very good? Am I able to explain my question well?
Yes, ma'am. Right now, I only got that example in my mind.
Someone else can share that. No problem.
Yes, ma'am.
Okay, in case of, I mean, those people who are from economics background, for them it might be very easy to kind of relate that oftentimes whenever you have a certain kind of policy which is implemented, then to see that what is the impact of that kind of policy, then you can use this kind of differencing in difference analysis where the difference can be between observing the data from based on the variables. I mean, you will have your x's and you will have your observe the dependent variable, and you break your time period based on before and after. For example, in case of there was a lot of research which was being done which related to the economic reforms in India. So that kind of analysis can easily break into the two time periods kind of analysis. Is that clear? Similarly, you can oh, I don't know, where did I click that? Yeah. All right. So that was one example. Now let's move on ahead. So this is the difference in differencing technique, and now what we want to do is we want to see that what are the assumptions for pooled. Sorry.
Excuse me, madam.
Yes,
madam.
please.
Good morning, madam. Good morning, madam.
Yes, please. Yes, I can hear you.
मैडम मैं पूछ रहा हूँ कि एक बार काइंडली ये एग्जांपल जो आपने रिपीट करा ना न्यू इकोनॉमिक पॉलिसी का एक बार फिर से बताएंगे, मैं कुछ समझ नहीं पाया.
See, if suppose you want to analyze the impact of one of the important variables, that is a policy variable. All right, suppose there is a change in the policy. For example, when the economic reforms happened. So in that case, you can use the difference in difference method with your panel data.
In this research, what will be the unobserved attributes?
No, so unobserved attributes will be easily, I mean, the attributes, the features which are there in the economy, which are likely to be, which can be easy. So I can show you here in this previous board itself. Yeah. So in case of when you are going to combine your time invariant, the time constant, here that is what we are saying, that in case of our unobserved attribute is when we are combining the time constant variable, which is your AI, with your error term, which is going to change over time, and where we are using this here the t will now be 2, wherein you will be able to apply your difference in differences estimator to remove your unobserved effects, which will be kind of now combined in this composite error. Is that clear?
Madam, I just want to know the variables, unobserved attribute variables and economic policy. I just want to know the variables.
Yeah. So for example, so you are anyway, you are going to have your set of explanatory variables, right? And then there can be variables which you are not able to include in your model. And your dependent or your dependent variable is your economic growth. So in such cases you can utilize your so basically what you are going to do is you are going to group your data into 2 categories, that is before the policy implementation and after the policy implementation, and then you apply your difference in difference estimators, where you are going to, for the before that, what you are going to do is you are going to take out the mean of all those xi's and see the impact on your yi's, and then you can compare it with in the same way with after policy, right?
Thank you.
Okay, so then what we can do is, I will move on to, yes. So in case of your in case of panel data, then the first kind of easiest or the simplest method is your pooled OLS. All right, using the pooled OLS, we are going to see that what you were asking, using first differences. All right. Now, when we are going to do this, what we do is that for each case which we are denoting by I, our model will be now YIT is equal to B1 XIT1 plus, again you go to next, B2 XIT2 plus, and you keep on moving on up to BK XITK plus, this is your time constant variable plus mu IT, where your t ranges from 1 to n. All right. Now here we want to say that XIT, here you will be able to see how we are applying that, is that your XIT will be, this is your policy variable, is your policy variable which is binary in nature. All right. Now, this is the kind of analysis that you can do. Now here, what we are doing is that the assumption that we are going to use in this case of pooled OLS first differences method is that the explanatory variables, they change over time. So they are varying, or they are varying over time. They change over time, but there is no perfect linear relationship between your xi's. So between your explanatory variables, we are assuming that there is no perfect relationship. All right. So then what is going to happen is that we are going to go back to our same assumptions, which we have been keeping for all our analysis, is that the expected value, which is going to be your mean, is am I audible?
Yes, madam, you are audible.
Okay.
Clearly audible.
Okay. So there is. Okay. So then for each time period t, so first we talked about for each case. Okay. Then for each time period t, what we are assuming here is that the expected value. So we know that the expected value will be mu it conditioned upon x, I and ai will be equal to, will be equal to 0. What it means is that the expected value of the errors is expected value is given such that in all time periods, the unobserved its unobserved effect will be 0. So what we want to say is that this is basically an assumption to ensure that explanatory variables, this is what shows that explanatory variables are strictly exogenous. So this is first assumption. That is your expected value of the error, given that the explanatory variables in all time periods and the unobserved effects is 0. The second is so the second assumption is that the variance of differential errors, which can be given as variance of the differential errors conditional upon the xi's is constant, which is equal to sigma square. All right. Now, what does this imply? So this assumption implies that the explanatory variables are strictly exogenous. This assumption implies that the differenced errors are, I should write here, differenced errors are homoscedastic. All right. Now, what it also means, what is another this requirement is that the differences in the errors are also not related to the excise. So that is the third thing that we want to do, is covariance that between the differenced error terms all right, where you can note here t is not equal to s with the xi's are independent variables is equal to 0. So what it means is that the error terms are not correlated to each other, and also the conditional to the explanatory variables. All right. Now here, conditional upon, what we want to say here is conditional upon xi, conditional upon xi's and the differenced error terms are independent. This is the implication. And also the assumption is that they will be normally distributed, and therefore we will be able to and therefore we will be able to apply our usual T and F distributions or tests. So these are the assumptions which will let us apply the usual T and F distribution in our hypothesis testing. All right. So now, what are the as I had mentioned in the beginning itself. So now we have seen that what is the situation where we can utilize the difference in difference method, but what are the problems or what are the drawbacks of differencing the data? So the drawbacks here is that number one is the main the main thing is that it cannot be utilized when the explanatory variables do not vary over time. If they don't vary too much over time, then this method will not be useful. The other drawback is that as I had shown in the last board, that there is assumption of strict exogeneity. Now that assumption of strict exogeneity of the explanatory variables is not necessarily possible in many cases. All right, not necessarily possible, or it is difficult to go with this assumption. All right. Another is if there is a problem related to measurement. If there is problem related to measurement of any of the xi's, then we cannot use the differencing in the data method. So we have seen that first we did that we can utilize difference in method in case of panel data. So that is the simplest or the first step. If your data does not follow these kind of assumptions and does not fit, is not able to take these assumptions, then what we do is we move on to the fixed effect model or fixed effect estimation. In case of fixed estimation, just the way we did in case of first differencing, we are again here also we are going to transform. We are going to transform the transform our variable, or we are going to use the transformation in the model to remove the unobserved effect. That is again we are talking about the time constant unobserved effect. Now in this case, what we can do, we see that if our model is like YIT is equal to B1 XIT plus, so suppose you have only one explanatory. For example, this example is for one explanatory variable. So if you have one explanatory variable, then your YIT is equal to BXIT plus AI, which is our time constant variable, plus mu IT, which is your error terms. All right. Now here what we want to note is that for each case, for each I, what we do is we take an average. All right. So to do that, what we will do, we are now going to estimate y I bar, or I should continue with the same notation. That is yi bar is equal to b1 x, we are having only one variable, x I bar plus ai plus mu I bar. So basically now what we are doing is, in the fixed estimation, in this equation, what we are doing, we have also one more component, which is that if we include the intercept B naught, then this becomes an in between. So this estimation is known as within. So in case of fixed effect model, this is known as within estimator, or this is known as within estimator estimation of fixed effect model. And in this analysis itself, if we are going to also see the impact, include the impact of intercept, that is B naught, then it would become a between fixed effect estimator. All right. Now, what we do is we are going to subtract we are going to subtract these two equations, which I have shown here, this one and this one. So to do that, we will have YIT minus YI hat, sorry, bar is equal to B1 XIT minus XI bar plus mu IT minus mu I bar, where your T range is from 1 to T. Now, in this equation, what we are basically doing is, this is known as time demeaned, because you have introduced, you have done the mean of your data, and that mean of data will be able to take care of removing the time component impact here, and therefore this is known as time demeaned data, and this can be used for undertaking. So after doing this, you basically apply your pooled OLS. All right. Now, this is also called as the within fixed effect model of estimation. Now here you remember that we are still continuing with the assumptions which we had discussed in the last board, where we were talking about the exogeneity, the strict exogeneity of the explanatory variable, and therefore we are going to continue this with this, as if we are able to continue with this assumption that the xi's are exogenous, strictly exogenous, then we can say that the fixed effect estimator is unbiased. All right. Now, but fixed effect estimation also allows for the if there is any arbitrary correlation, if there is any arbitrary correlation between your time constant variable AI and explanatory variables, that is your xi's. All right. Now, if so, here what we are saying is that there is a possibility that there can be an arbitrary correlation between AIs and the explanatory variables, that is xi's. But if we think that the AIs are, if we want to say that if AIs are completely uncorrelated with the explanatory variables, then so fixed effect is going to let you assume that there is a possibility that there can be arbitrary correlation between AI and explanatory variable. But if you want to do an analysis wherein you want to say that there is no correlation between your time constant variable and explanatory variables, then what you should do is you should use random effect model. We will do that after this, but before we move on to that, let's do the assumptions for fixed effect model. All right. Now, in order to do that, so what are the assumptions here? So assumption is that for each case, that is for I, YIT is equal to B1 XIT1 plus, we move on up to BK XITK plus AI plus UIT, where T ranges from 1 to N or 1 to T, whatever. Now, here, this is for one particular kind of random sample. All right. So this is your random sample from the cross section. Then, what are the assumptions? So the assumptions would be that each explanatory variable over time varies or else changes. All right. And there is no perfect linear relationship between xi's. Okay. Now, if we continue with that assumption, then for each, so this is from the perspective of case. Then for each time period, what we want to say is that the expected value of the error term conditional to the xi's and ai will be 0, right? So what it means is that the errors for the explanatory it is given that for time constant variable and for the other explanatory variables conditional to those, the error terms, the expected value of error terms will be equal to 0. We are continuing with our assumption about variance. So the variance, again, we are going to assume that the variance of the error terms conditional upon your xi's and your time constant, this thing will be a constant, which is sigma nu square, or it can also be written as variance of mu or error term, right? Now, same other assumption as we did in case of the differencing indifference method, there was that we continue with assumption that when t is not equal to s, the error terms are also not correlated. So covariance mu it and mu is subject to or conditional to xi's and ai's will be equal to 0. All right. And also our last assumption, as we did in the other case also, is that we are here saying that xi and ai, conditional upon xi and ai, the mu it will be independent and will follow normal distribution, and therefore you will follow normal distribution with mean 0 and sigma u square as your constant variance. Now, if this is the situation, the question then arises that whether we should, because the assumption, as you can see, note down the assumptions, those are quite similar in case of first differencing. So the assumptions in first differencing and the assumptions in fixed effect model will cause a confusion that which model should be used. Now, so what we want to do is that if when when can we use the fixed effect model and when can we use the first differencing model is that when I'm writing it here. So when t is equal to 2, the fixed effect estimation and FD estimation are identical. That means they are the same. And so it does not matter that which one should be used. So you can use whichever you want to use in case if your t is equal to 2. And when your t is greater than or equal to 3, then the choice between you can make a choice between these two will depend on the relative efficiency of the estimators. And how do you decide that? Is that it will depend on it will be determined or it will depend on what is the, if there is serial correlation in the error terms, that is your mu ITs, you see that there is homoscedasticity or not. And depending on that, you will be able to decide that whether you should be using the fixed effect or so. So when mu IT, your error term, is serially uncorrelated, okay, is serially uncorrelated, in that case, FE, that is your fixed effect model, is better model compared to first differencing method. All right, and also when t is large, and in addition to when t is large and n is not very large, then we should be careful in using fixed effect model. All right, so oftentimes it is difficult to decide between the two models whether the fixed effect model or first difference model should be used. Will depend on if your t is also large and your n is also large, and you know that the error terms are serially uncorrelated, then you can easily straightforwardly go for applying fixed effect model. All right, now so if if you have done that, then we want to see that what would be the situation in which we will use the random effects model. All right. Now, when we want to use the random effects model, what we want to first see is that we begin with our unobserved effects model, and we start with YIT is equal to B naught. See here we have introduced the error term, intercept term B1 X IT1 plus we go on up to B K XITK plus AI, your time constant variable, plus your error term, wherein your T goes from 1 to capital T. Now, this means here that the AI has mean 0. Okay. Now, when you are using the fixed effect or the first differencing method, your objective was to kind of eliminate the effect of AI, because what we wanted to say was, what we were expecting was that there will be correlation between there is a possibility of correlation between one or more explanatory variables, the xi's. Okay, but now suppose that we think, where did it go? So the arrow is not going down. Okay. So we were talking about fixed effect or first differencing method. Now suppose that we think that AI, your time constant variable, is not correlated. Okay, is not correlated with your explanatory variables in all time periods. All right, then this model here becomes, random effect model. Okay, so what it means is the covariance covariance between your explanatory variables and your time constant variable is equal to 0. All right, now in where your T is ranging from 1 to capital T and your J ranges from 1 to K. All right, so now what we want to introduce is one more component that we were talking in the beginning, was about introduction of term which is composite error, which is given as sum of error term and your time constant. So then our model which we were writing here, which was our random effects model can be rewritten as, or can be written as, YIT is equal to B naught plus B1 XIT1 plus, we go on up to BK XITK plus, we introduce here now the composite error term. All right. Now, we want to also see that if the composite error term, if the composite error term is serially correlated over time, then what is going to happen is that our OLS, that is our pooled OLS, and our T statistic will become incorrect or will be invalid now. So to solve this, what we do is we are going to utilize generalized least square model, and we should keep in mind that we can apply this only when we have large n and relatively small or smaller t. So this is the situation where you can use random effect model and what we can do is that in case of you remember, in case of fixed effect model, we had demeaned the data. All right. Now, in case of random effect model, it is also known as the quasi-demeaned data. It is also it is going to utilize quasi-demeaned data. All right. So, in case of fixed estimator, what we had done was we had subtracted the time averages from the corresponding variables, right? Whereas in case of random effect, what we are doing is that we are doing the transformation by subtracting a fraction of that time average. So then basically what is going to happen is your model in the random effect model will be like this. YIT minus theta YI bar is equal to beta naught 1 minus theta plus B1 XIT1 minus theta XIT1 bar, plus like that we go on up to BK XITK minus theta XITK bar plus our composite error, that is this minus theta I don't know it's and is visible or not. All right. Now, in this case, what we are basically doing is that in case of fixed effect model, we had taken the average and we had done the demeaning of the data by taking that average for all. Now, here what we are doing is we are subtracting a fraction, right? So, fraction of time average. Now, what is the implication of this? The implication of this is that since our theta is equal to 1 minus sigma mu square given sigma mu square plus t sigma a square, and you are going to do the under root of this. Now, hence, what we want to say is that the fractions in this case will depend on sigma mu square and sigma a square and capital T. All right. So in this case, now what is happening here is that your generalized least square estimation is now going to be our simple OLS. Simple OLS estimation. All right. So basically what we have done is we have allowed the constant explanatory variables in our time constant explanatory variable, that is that AI in our model, and therefore now what we are doing basically is this is how we are creating an advantage over fixed effect and first differencing model, right? So because we have introduced this component which is going to do because we are going to use this theta as a fraction of the meaning, and so what we want to say is that this estimation, this is going to show that the random effects model how it is related to pooled OLS and fixed effect estimation is based on what is the value of our theta. Oftentimes theta is not known in our estimations, but theta is likely to fall between 0 and 1. All right, it generally lies between 0 and 1. So now what we can do, how we can relate it, is that when theta is equal to 0, what we are going to get is the pooled OLS. Okay, and when theta is equal to 1, then fixed effect is what you will get. But in practice, it is not going to happen that you will get theta as absolutely equal to 0 and or theta is equal to 1. So therefore what happens is we will not be able to completely say that our model has become a pooled OLS or it has become a complete fixed effect model. All right. So, and as t gets larger, as t would get larger, the results from the fixed effect and random effect, as t gets larger, the results of fixed effect and random effect model will be very similar. All right. So now what I will do is I will continue in the, should I stop here or I should continue? And what it is, time is 11:30. Yeah.
Ma'am, it's up to you. Like, if you want to continue, you can continue, or you are looking for a this break, so we can have a break also, ma'am.
Okay. I think I'm going a little bit slow, but no problem. What I will do is, I will resume from here itself, and we will start after half an hour.
Okay.
And because then there is a possibility that I will be able to cover the remaining portion of this, and if I have time, I will also take up one example.
Ma'am, there is no issue. Like, even if you want to extend your time, even in any session, even after the half an hour you want to extend, or after the break also you want to extend, it's up to you. You can extend. There's no SS problem, ma'am.
Okay.
Okay.
Yeah. Yeah.
So
Okay.
yes, ma'am. Dear participant, we are going to take a break of 30 minutes. So we are not going to stop this meeting. We are just pausing this meeting. So you can pause your meeting and then you can come back again near about at 12 noon. You can join us. So, okay. And I request to all participants, please submit your feedback of the first session. Okay. And dear all participants of the previous 2 days session, all study material we are going to share today. Okay. Thank you so much. Thank you so much, ma'am.
Thank you.
Shall we start, ma'am? Ma'am, you are mute.
I forgot. Yes,
No
we can
problem.
start. Yeah.
Okay, okay. So, dear participants, welcome back, ma'am and participant. I think in a first session, ma'am discussed about the all theory related to the panel data, fixed effect method, and random effect method. And part still is missing, so she is going to cover in our second session and third session along with software. Ma'am, it's up to you. Even like as you want to extend some time, so you can extend your time. We don't have any objection.
Okay.
Okay, ma'am. Thank you so much.
Okay. Thank
Oh,
you. Thank you.
thank you. Yes.
All right. So, students, are you able to see the same board where we were discussing about the random effect, and we have introduced the component of fraction of time average?
Yes, ma'am.
Am I sharing the same board? Okay.
Yes, ma'am.
Okay. Fine. So, we were yeah. So we were discussing about the difference between the difference between what we were doing in case of fixed effect in what we did in case of first differencing method, and then what we did in case of fixed effect model, and how our random effect model is different than the fixed effect model. In case of random effect in case of fixed effect model, what we did was when we did the difference here, what we were taking was the average. We were doing the demeaning of the data, whereas in case of random effect model, what we are doing is we are demeaning in terms of a fraction of time average with respect to fraction of time average. All right. Now, yeah. So now what we want to do is we want to see that what are the assumptions of random effect model. All right. And in order to do that, what we want to see here is a lot of things will be quite similar, but we need to pay attention here is that you remember that we have I cases, and so for those I cases, our model can be stated as YIT is equal to B naught plus B1 XIT1 plus BK, we go on up to B2, B3 like that, BK X ITK plus AI, which is our time constant variable, plus error term, where T ranges from 1 to capital T. All right. Now, what we want to do is that here for each time period, the expected value of error, given the explanatory variable for all time periods is going to be 0. So expected value of the errors for all time periods given the explanatory variables and the time constant variable will be equal to 0. So this is our number one assumption. Then what is the next assumption? Next assumption, as we have been doing now, is that the variance of the error terms with respect to or given your xi's and ai will be a constant, which is variance of UIT is sigma square with a subscript mu. Now this is for the error terms for all p ranging from 1 to capital T. Now the next assumption is that when t is not equal to s, we also want to say that the errors are not correlated to the explanatory variables, and that we and also the time constant variable, so that we can write here as covariance between the mu it and the mu is conditional to your xi's and alpha ai is equal to 0. Now, we also know that we want to assume that there is no perfect linear relationship amongst the explanatory variables. So that can also be written in terms of expected value of your ai conditional to xi is equal to 0, and the variance of ai with condition of xi's is a constant, which is here we were assuming it for the error term. So here we are doing it for the time constant variable. So it will be sigma square again, but with a subscript a. All right. Now, these are the assumptions of random effect model. The other thing that we want to share here is that there is also an approach which is known as the correlated random effects approach. All right. Now, this is an alternative approach in case of random effect model, where what we do is we see that the time constant variable is, for example, is correlated to the explanatory variables or the xi's. All right, and your ai is a random variable. So in order to do this kind of random effect model, what we can see is our model can be written as yit is equal to b1 xit plus, suppose if it is for one explanatory variable, then ai plus uit. Then now what we want to do is, here we want to allow that ai is correlated with time average of explanatory variable. All right, so that can be written as ai is equal to alpha plus gamma xi plus ri. All right, now what does this imply is that here this indicates that what we are going to do is the covariance. the covariance of this xi bar and r is equal to 0. We are assuming that there is no correlation between this x, that is the time average of xi, is not related to this r. So now what we can do is we substitute this equation in this equation, the one which we had shown earlier. With that, what will happen is our equation now becomes YIT is equal to alpha from here, alpha plus B1 XIT plus, we will have this gamma XI average plus RI plus error term mu IT. Now, when we are going to run, when we run this random effects equation, the estimates that we will get for B will be similar to fixed effect model. All right, and if this gamma happens to be equal to 0, if this happens to be equal to 0, then we get our usual, the way we did earlier, we get that kind of random effects estimation. All right, now the what we want to also see is that what are the advantages of using panel data, and we will also again do the summary of what we have done, and we will see how we can apply it to one of the examples. So we know that in case of panel data, the advantages of panel data are that it usually contains more degrees of freedom, and there is more sample variability. All right, then the other thing is that there is greater capacity for capturing human behavior, because you will be able to analyze, you will be able to capture that based on your time variant and time constant, inclusion of time variant and time constant variables, and therefore you'll be able to include in your analysis the heterogeneity amongst the cases. All right, and then of course is that there will be, it is easier to undertake the statistical inference based on the panel data. Then what are the disadvantages? All right, now what are the disadvantages is that it is difficult to, as I had said in the beginning itself, that it is difficult to get the observations on excise for same cases over the time, and that is why the difficulty is in getting information about individuals over time. All right. Now the other thing is that we need, so in order to do that, we have to keep a track of the same individuals or the same units or same firms, and it is also possible that over the time the situation of those firms or individuals would have changed. But panel data in that, so that is why that it is difficult to get the data for those individuals over time. And also this, not just in case of individuals, but also in terms of individual economic units. So because their composition also may change over time. Then if their economic composition changes over time, then it becomes difficult to use those same units as your units in the analysis. All right, so those are the disadvantages of using panel data. All right, now so now what we can do is we will see the summary of what we have done and what are the different kinds of things that we are doing, and can we relate that to, it did not get saved. Yes. So as of now, what we did was that we identified that there are in case of panel data there are several cases, and we undertake observations of those several cases. All right. So now if we want to see that what we have done until now is we have discussed about pooled OLS model. All right. And then we discussed about fixed effect model, right, wherein what we did was that for each kind of case we got the data in terms of cross section, and then we were allowing the time constant variable to be effective there. All right. And then in that also what we did was we saw that how the fixed effect model can be within group model, and also it can be a between model of fixed effect. And then we discussed about the random effect model, in which we also saw that if we were to do a modification, then what that modification will lead to in terms of utilizing the correlated random approach. So in fixed effect model, in random effect model, we also did talk about random effect model where we are allowing correlate, which is basically correlated random effect model, in which we were allowing correlation between the explanatory variable in terms of with respect to the time constant. So basically you were allowing correlation between your time constant variable and the explanatory variable, right? Wherein we did take the average and we saw the coefficient of that average and we moved on. All right. So now what we can do is we can take up the example of we can take the example of applying this panel data in all these different situations one by one. Okay, so in order to do that, for example, we can say that we can consider a model based on an example where suppose that we want to estimate so we have chosen a linear cost function. Okay, and in that linear cost, in that estimation, our dependent variable is given by C, and we continue with our coefficient values. And for example, this is one of our explanatory variable. This is the next kind of explanatory variable. And now what I'm doing here is I'm following the example which is given there in Damodar Gujarati's book, which relates to the linear cost function estimation for the airline industry. So in this example, what we are doing is we know that I is our ith case and t is the time period. All right, and suppose that for simplification we are keeping there are 6 cases. All right, so I ranges from 1 to 6 and t ranges from 1 to 15. All right, now in this case we also want to show that what are the effects of these different kinds of independent variables on the cost function. All right, now in order to do that, what we see here is we have 6 cases and 15 time periods. Therefore we basically have 90 observations. All right, now we are also going to assume here, I missed on this explaining this concept, that the explanatory variables, which are these 3 explanatory variables, these explanatory variables where Q is given by your output of the industry, which is in terms of revenue generated or total sales, and C is of course your cost function. So, and PF here is your fuel price, and LF is your load factor. Now, what we want to say here is that these explanatory variables, all these 3 explanatory variables are non-stochastic in nature. All right. Now, what do we mean by that is that if they are stochastic, then they are not correlated with the error term. So if they are stochastic, then they are not correlated with error term. This also means that these explanatory variables are strictly exogenous. We did talk about that. Now, what it means is that the variable is exogenous. It means that it is not related to its present past value as well as future value of present, past, and future values of the error terms. All right. Now, you might have already seen that in your earlier sessions that whenever we are assuming that whether the explanatory variables are stochastic or non-stochastic, we need to understand that what is their linkage of the explanatory variable with the chance factor. And that chance factor is directly linked to our error terms. And that is why in case of this assumption here, that the explanatory variables are strictly exogenous, this means that these variables do not depend. They are not related to their present or past or future error term values. All right. Okay, so we move ahead with so yeah. Now what we do is we first thing that we undertake a simple pool regression. All right. Now, in case of pool regression, what we are doing here is, and we will also, of course, see that we will also check that there should be that there could be a problem of autocorrelation or spatial correlation in the data, and we should know that that what is the value of the Durbin-Watson value there, Durbin-Watson statistic there. So after doing those kind of preliminary tests and about the data and pool regression, we will be able to find that whether there is something which is completely is there any component which is completely an individual factor, as one of you had already mentioned about the example of, and therefore that management is the kind of individual component or individual factor. All right. So now what we want to do is that we want to say that each of this we want to now include each of the disturbance term or the error term, and we want it to be subsummed in the disturbance term, that is the individuality, the heterogeneity. Now if we want to see whether the error terms can be whether they are correlated with explanatory variables. So then what we do is we modify our equation to beta 2 fuel price and beta 3 coefficient for our load factor and beta 4 coefficient for management and the error term. Now here as we were saying that we want to see whether what will be the impact of the individual kind of characteristic in the same analysis which we started with. All right. So now here what we want to say is that this M management can be a time variant factor or it can be a time constant factor. All right, it depends on case to case. All right, now if variable M is, as we know that if suppose it is not, we are not able to directly observe it in our model, then we will not be able to measure its impact on the cost function, and so we do it indirectly by doing this component management factor is now we are taking it as alpha I plus mu I t. All right, now here this alpha I is the heterogeneity effect or the individual effect, and that is going to have an impact on the cost component. All right, now we know that it is not possible to measure the alpha I directly, so then what we do is we are then going to introduce, as we had discussed in our previous class, we are going to introduce the composite error term. And that composite error term you remember this. So when we introduce this composite error term, then our equation would become CIT is equal to B1 plus beta 1 plus beta 2 PFIT, which is your fuel price, plus beta 3 load factor, and we have introduced this component which is the composite error term. Now with this what happens is that there is a possibility that what we can do is that we see that the VIT is the component which will now have the component of error term included in it, and also the time constant variable there. So that is what is going to give us. Now after this, if suppose we think that we find that the explanatory variables xi's are correlated with the alpha i's, with one or more alpha i's, then it is possible that our ONS estimation will be inconsistent, or it will be biased also. So then, in order to do that, in order to rectify this concern, as we did in our theory class earlier, what we will do is we will move on to our fixed effect model. Now here what we want to do is, in case of fixed effect model, we are going to introduce what is called as dummy variables. Now, in case of introducing the dummy variables, what we want to do is we want to address the heterogeneity component, which is the individuality component. And therefore, what we are going to do, we again start with the same equation, which was our cost function was CIT is equal to beta 1 I plus beta 2. We will have this same equation there, and out of that, what we are going to take is, this was our original equation, from where what we are now going to introduce is the component of dummy variable. So what our equation looks like will be alpha 1 plus alpha 2 d2i plus alpha 3 d3i plus alpha 4 d4i plus alpha 5 d5i plus alpha 6 di6 d6i plus beta 2 qit, our output, plus beta 3 price and load factor and error component. Now here, what we want to see here is, so what we want to see here is that we have introduced the dummy variables. Now, why we are introducing these dummy variables is because we want to see the individual impact of those individual cases, which are those different airlines in our example. All right. Now, when we solve this, our fixed estimators can be estimated, and what we are going to get is, we are going to get the slopes for these individual cases or individual dummies as well. Oops. Yeah, so sorry for that. Now what we are going to do here is the fixed effect, as we have discussed in our theory section, within group estimation. So when we want to do the fixed effect within group estimation, basically, as you would be remembering in our theory, this thing we had seen that whenever the whenever your when you are letting the mean corrected values being used, which is your demeaned values, then that is where you are going to utilize your fixed effect between estimation. All right. Because basically what you want to say is that the two the expectation of the two mathematical models, the two models here with the mathematical expectation of these two models is going to be identical. We are going to do all this example in our session today in the afternoon, where we will do this with the data set that we have shared with you. All right. Can you please excuse me? There is an urgent call. It is coming time and again. Just for 2 minutes. Right, sorry for that. So now what we are going to do is we want to see that in case of within group estimation, the disadvantage here is that the variables which are I'm not right. The variables which are not or which do not vary. Yeah, the variables which do not vary over time, or which are not varying over time, then in those cases, if we use the within group kind of estimation, then you remember that we also did the first differencing, and that is going to kind of fade out your variables. because those observations there are not going to change over time. So when you are going to apply those, in case of time variant, in case of time variant, in case of time invariant components, those are going to fade out when you are going to do the first differencing, and therefore in case of fixed effect model, we will not be able to utilize the within group kind of estimation. All right, now so if we were to now apply that same example in case of random effect model, then what is going to happen? So here, as we had discussed in the theory also, that when we, in case of fixed effect model, we are introducing the dummy variables. In case of fixed effect model, we are introducing dummy variables in order to see the impact of individual cases or individuality in terms of heterogeneity across the individuals, right? Now, with inclusion of dummy variables, it is also possible that the when you are going to see the number of variables on your in the model, then those number of variables would now be increasing depending on the number of cases that you have on your in your matrix. So when you have more number of those cases in the matrix, then the same way your dummy variables are also going to increase. Now, when your dummy variables are going to increase, that all of this is going to cause a loss in degrees of freedom. So now, then if that is the case, then what should we do? So in order to take care of that, we can utilize the random effect model. And in case of random effect model, we go back to the same equation which we were doing. So we are now again going back to the cost function example. So we are estimating the cost for the airline industry, where we have six of those firms: beta 1i plus beta 2 QIT plus beta 3 fuel price plus beta 4 load factor and mu IT. Now here, what we want to do is, as in our fixed effect model, what we did was we were considering this component as fixed. All right. Now, what we are going to do here is, in our, we were also, that is why we were writing it as without the T component. That is in our theory, this thing understanding, we were writing it as AI. Everywhere we were discussing that as AI. Now, what we can do is that this intercept component can be written as beta 1i is equal to beta 1 plus epsilon I. Now here, what we want to say is that this epsilon I is the random error term. All right. And of course, we are going to apply all those same assumptions, which includes that the mean value of the error term with the mean value 0 and constant variance, all right, which is sigma epsilon square. All right. Now, when we are doing this, so now we can do this for our example, and we will see that in our example now the cost function will be beta 1 plus, so we are replacing here this beta 1 plus beta 2 QIT plus beta 3 PFIT plus beta 4 LFIT plus, we are bringing this component here, epsilon I plus mu IT. So basically now your B1I is now written here and here. So what does this mean is this is equal to beta 1 plus beta 2 QIT plus beta 3 PFIT plus beta 4 LFIT plus. Now what we are doing here is that this random term, this term which is combination of random error and the disturbance term, can be written as WIT, where this is equal to epsilon IT plus mu IT. All right. Now here what we are doing is, again we are introducing what we had discussed in our theory class as the composite error. All right. Now this error component is also sometimes known as the idiosyncratic term. This is also known as idiosyncratic term because what we are doing is that it is going to vary over each case, as well as it is going to vary over time for each case. All right. And we will continue with the assumptions that we had made in our theory class, where we were saying that this random error term will follow normal distribution, will follow normal distribution with mean 0 and variance sigma square, and also our mu IT will follow normal distribution is normally distributed with mean 0 and sigma mu square as the variance. The expected value of error term conditional upon mu IT will be 0. Expected value of epsilon I and epsilon j will also be equal to 0, where I is not equal to j. And of course, we will have the last same condition, that is mu IT, expected value of mu IT and mu IS, where I is not equal to s, as equal to expected value of mu ij. Mu ij is equal to expected value of mu it. Mu is is equal to 0, which means I is not equal to j for given, and t is not equal to S. These are the things which we have done in great detail in the theory class earlier. All right. Now here what we want to see is that the error components here are not correlated with each other. The error components are not correlated with each other and are also not autocorrelated across the cross section and time series units. So those are the assumptions, and that is why this our composite error term is also not correlated with, and another assumption is that our composite error term is also not correlated with any of the explanatory variables. All right. And how are we going to do that? You will see this in the practical class today, where we are going to undertake the Hausmann's test in Stata as well as in eViews, and you will be able to see that for your random effect model, you are going to also do the Hausmann test, and that is what is going to tell you whether your composite error term is I mean, it should not be correlated to any of the explanatory variables. All right. Now, besides that, what you are going to do is in your practical today, yeah, so that is, I think that's all what that we are going to apply in case of utilizing the when we are doing fixed effect model and when we are doing random effect model in case of panel data estimation. I think I ran through the example very quickly. All right. So fine then, can we go ahead with the application of the data which I have sent at can we do that at 2 o'clock now today?
Yes, ma'am. This data set we have already shared with us participant.
Okay.
Even we have mail also, when we have shared in the chat box also. So I think everyone, they can be do handset practice with you.
Okay. So should we, I mean, close the session now, or if there are, yeah, oh, I forgot. If there are any questions or if you have any confusion, please let me know. And we will do all this in with the real data which is there from the secondary data set, in which we will have several exercises, and those will be regressed, and we will see the impact of that on our dependent variable. So, and what the data which I have shared, that is from for estimation of agricultural productivity. So in case of the data which you are going to run today, and what you might have already gotten, that data, yeah, that data has the dependent variable, which is your productivity, or I think it is production. It is production, and which is a function of several variables, which are mainly the gross cropped area for agriculture, gross irrigated area, and then we have the soil quality, and we have fertilizer, how much fertilizer is being used, how much is the mechanization. So for mechanization, we are going to use the number of tractors which are there, And this entire set is state-wise data. So our cases are the states, and there are time periods. So I think there are 7 or 8 independent variables. And we are going to then run the fixed effect as well as the random effect in Stata as well as eViews. Yes, please, ma'am. Please go ahead.
Ma'am, can I ask one question, please?
Yes, please.
Actually, your session was a bit technical, and I actually was trying to understand what you were writing. But can you please simply explain, like, what is the take-home, crux of the entire session in terms of applicability of fixed effect and random effect models, as to like when we can apply fixed effect model and when we can apply the random effect model?
Okay, yeah. So see, what we do is whenever we have the panel data, so whenever we have the panel data, first is the simplest way that we can do is to do a pooled OLS estimation. All right, so pooled OLS is nothing but it is like doing several cross-section analysis together. So because just a second, ma'am. I will take maybe I will summarize. In fact, this is a good question that he has asked, and so that will help me in explain. I was under the impression that all the students have this technical knowledge, and therefore I went going on quickly utilizing those notations for the model. So what I will do is I will take maybe 5 to 10 minutes and I'll summarize this, and you will be able to understand that. Yeah. So when we are talking about the panel data, so what we do is first is, of course, we do the only difference here in case of panel is that you will be having same cases, and those same cases will be observed over several time periods. All right. And in order to see that what is the kind of method that we can use in different situations, what we want to say here is that first you can do pooled OLS model, in which is mainly like a combined regression, or you can say combined OLS. All right. So where you are doing the OLS for these several cases, that is the simple way to put the OLS. Then in case of fixed effect, what we are doing basically is that we want to see the effect of the component which is heterogeneous, and that is your based on your AI. That is what we have been saying in all our analysis. That is what is given by the AI. Now this AI is actually individual impact. All right. Now that individual impact, in case of fixed effect, one way to see the fixed effect is where you are doing the fixed effect with dummy variables. All right. Now, when you are doing the fixed effect model with dummy variables, basically what you are doing is you want to allow the model to capture this individual impact utilizing dummy variables. So in our example, what we did was there were six firms in our example. Therefore, we used 5 dummies in our example. So now basically what you are going to in the introduction of dummy variable, how your data will change. Suppose these are your y values, these are your xi's, and 1, 2, 3, 4, 5, and 6. So after identifying whatever are your xi's, then in your panel, what you are going to write here is your D1, D2, D3, D4, D5. So you are going to introduce, if the number of cases here is 6, so you are going to introduce 5 dummies there. So basically your number of dummies will be n minus 1. All right. This is in order to keep your degrees of freedom. Otherwise, this entire model will collapse. So you are going to utilize, adopt these 5 dummies. Now, what it means is, in case of the firm 2, this value D1 will be a binary value 1. All right. In case of firm 3, the D2 dummy variable will have a value 1. In case of 4, so like that up to 6. In case of D5, it will be 1, and remaining will be 0. All right. So this is what is going to capture this entire analysis, which is also known as the fixed effect least square dummy variable model. This is going to capture your individual effects. All right. Now here the problem is, in this model, there is a lot of loss of degrees of freedom, because you are going to utilize lot of dummies there, depending on how many number of cases you have. Therefore, this side, your entire number of variables are increasing. Therefore, it is not a very not always the best thing to do. All right. So in that case, what we do is, we in the theory we have talked about the second type. So this is 1, and 2 is where you use the fixed effect within group model. So in that fixed effect within group model, what we did was, we wrote that equation YIT, right? And we also estimated an equation where what we did was, basically to take care of this component T, we did an average, right? Now this, and then what we did was, we did the first differencing. In that, what we did, YIT, of course that entire equation would be here, YIT minus Y bar, and then we did the entire thing here. Now this equation is what is, so I'm trying to do it in a simplified way, in a quick mean. So this kind of, and then what we do is, then again after doing this, you are actually going to do the ONS estimation. In this kind of analysis, what we are basically doing is, this is known as demeaning the data.
In first case, madam, what if I get you correctly? Please let me know.
Yeah.
You like we want to know the effect of firms,
yes,
individual firms.
Cases. Yes.
And that is between the groups, the fixed effect between the groups. And then second case, we want to know whether the effect is within the firm itself or not.
Yes.
So this is the okay. That's why we created these dummy variables.
Yeah, but I mean, although we are doing this, but this is not always necessarily a suggested model. Because see, most of the times in your panel data you will have many number of cases here, right? So when you will have many number of cases here, then your number of dummies is going to increase. Like in this case, we are keeping it simple, only six cases. But in oftentimes in your research, you will have several cases here. Several cases, and of course several time periods also. But with the number of cases, your number of dummies will increase. So your degrees of freedom will be lost because of this. And that is why it is better to go with this kind of fixed effect within group model.
Okay.
And
thank you, madam.
And if you are not able to still get the variable value, and if there are still the problems which are related to the core. Now here another thing is that in all of this we want to assume that the assumption mainly is that the error terms are not correlated with the xi's. Okay, this is one big thing. But it is a possibility that, because it is a possibility that error terms or the individual impact, this here AI, it is possible that you want to make this AI as time variant or having some impact of time, and also it is possible that in your data set the error terms are correlated to the explanatory variables. If that is the case, then is the third step, which is, so basically your first, then either you are going, first you do that pooled regression. If that does not work, you go to the fixed effect least square dummy variable model. If that also does not give you a very good fit, then you move on to fixed effect within group model. And if this also you think might not be able to address all the assumptions which are there, then you go to random effect model. So in case of random effect model, basically what you are doing is you are merging that individual component with the error term component, and that is where you are going to utilize your composite error, and thus you are making this time invariant factor also time variant factor. And also in case of random effect model, what we are basically doing is that for each another thing in the fixed effect model, we did not have the intercept in the equation, whereas in case of random effect model we are allowing the intercept to be there. What it means is that there will be certain component which will be given for each case. And so in your analysis, it is possible that some firms are going to begin with a higher value of intercept, and some are entering in your model or in your data with a lower intercept. So those individual intercept values will also be taken into consideration when you are doing random effect model.
Okay, thank you, madam. I think we will get more clarity when we have this practical session on
Ma'am, actually the session was very nice. Some of the doubts you are clear in equation models. We sometimes use the model but don't understand the logic behind it. Now I can able to capture when we explaining the equation very nicely. I can see that's okay. Very fine, ma'am. Thankful to clear-cut explanation, because when we read the Baltogi books, all these books are very difficult to understand for that. You have make it simple. Madam, one query I have.
Yes.
In between OLS and this random effect, madam, there is a model you have talked about, generalized least square model. So
yes.
Can you elaborate on that, where we can put it, that things into that?
Okay. So what we can do is, you remember we were talking about when we were using which in which here. I'm searching for that.
No, ma'am. Just you just show that where we can use. That's all. That's all, ma'am. That's okay for us. Only one clearance, ma'am.
Okay. Okay. So you remember that in case of fixed effect model,
Yes.
what we are doing is we did discuss about the first differencing, and then we did discuss about the fixed effect. And
yes.
in case of when we are doing the fixed effect, is first difference is utilizable when your number of time periods, when your number of time periods is only 2, then in those cases your both your fixed effect as well as your random effect will be
result is same.
Yes, result will be same. And whenever your time period is greater than the 2, so it is in those cases that you will have to make a decision between fixed effect and
GLS
and FD and first differencing. No. So then you remember that we did talk about that there should not be any serial correlation in the model. So that is where you are going to see that the random error terms it should be homoscedastic.
Okay.
Now, so those were the things which we were doing those assumptions, those series of assumptions were there. Now, in all of this, we moved on to, I think I will show here itself in this and in this brief summary where we are discussing, we did talk about composite error. Okay, composite error term. In this composite error term, we are summing the time constant variable and the error term. But this composite error term, I don't know whether we here we have mentioned this composite error term also can be serially correlated across time.
Okay.
When this is serially correlated, then what happens is that our entire analysis goes a waste, because our OLS estimation as well as our T statistics, they become invalid. Yeah. So in this case, when you observe this, then in that case you can utilize GLS. So basically, after doing all this, I mean, that is the further step. So that is, I did not do that. So first is you do the pooled OLS, then you do the fixed effect with dummy variables.
Yes.
Then you do the fixed effect within group model, and in that you are then you do the random effect model, and within that, the assumption here is that your composite error term is not serially correlated.
Yes.
But if your composite error term is serially correlated, then you will use GLS.
Okay, but how can we know that composite error is serially correlated? Is there any
you will
test?
do that. You will do that Hausman test. Just now I told you. When you are going to do your random effect model.
No, sir, ma'am, Hausman test is to choose between fixed effect and random effect. But for choosing GLS, how can we choose?
Yeah, so in that itself, you will also be able to find that whether the composite error term is also serially correlated or not.
Okay, ma'am, move the next period. You can show it in that so that we can be clear.
Yeah,
Thank you, but it was nice session.
Also, one more thing that you need to remember here is you will shift to GLS. That you can use GLS, but for that, no, you should have large number of
observations. N is large.
Yeah.
Yes.
Yeah.
Yes, N is large. That's okay.
Yeah. So that you must.
Yes. I may ask out of context. It is also cross-sectional data. Also, we can use GLS. There will be no problem.
Yeah, we can use GLS in cross-sectional data also.
But the condition is N should be large.
N should be large. Yes. And in case of cross section, it is far more easier because T is already small. I mean, T is only one there.
Okay. Yes.
Thank you. The option here is that in GLS, N should be large and T should be small. So in case of cross section, anyway, it is small.
No, time is not there now. One particular time is.
Yeah.
Yes. Yes, ma'am. Thank you very much. Okay.
Okay. So fine. Yes, ma'am. What should we do now?
Ma'am, we can take a break and we can join at 2:30 p.m.
Okay.
Okay.
No, can we start at 2 because I have then another class also. So.
Okay, ma'am. Okay, ma'am. Yeah. So, ma'am, 2 to at what time you would like to take this session?
2 to 3:30 or 4. It depends how these candidates are, because I will be here, but Dr. Pradhan, who is my postdoctoral fellow, he is going to run the stata and the e-views.
Yes,
and so because the same data set will be explained in two platforms,
two softwares.
Therefore, so there is possibility that it may take about 1.5 to 2 hours.
Okay, no problem, ma'am. So, okay, ma'am. So, dear participant, we are going to take a break near about the 35 minutes. So, please come on time at 2 p.m. We are going to start our third session on 2 p.m. And this session is specifically will be based on the software analysis based on two platforms, Stata and eViews. Okay, so we are not going to stop this meeting. You can join this meeting again and this meeting will be continued. So, ma'am, you can take a break. We'll meet at 2 p.m. Okay. Thank you so much.
And I will. I have saved all these boards, and I will share this with you over email.
Okay, definitely, ma'am. Definitely, ma'am. Okay. Thank you.
Okay. Thank you so much. Thank you.
Yes, ma'am.